back to another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're continuing through our series within VMware. That's right, we're coming back at you with more VMware Certified Professional version 6. And in this episode, we're going to be looking at resources and some of the things that you can do to manage them. Joining me in the studios today is none other than Mr. Don Pezet. Don, how you doing, sir?
I'm doing just well, Wes, and I am excited to jump right back into vSphere. Like Wes said, in this episode, we're going to be taking a look at resource management, and we've kind of already seen this a little bit. When we were creating virtual machines back a handful of episodes ago, we saw where inside of each virtual machine, you could configure what's effectively a resource governor, right? We could limit the amount of CPU utilization or the amount of RAM that a machine could access at any given time. We could also set up reservations where we reserved a certain amount of CPU or a certain amount of RAM to be available for a virtual machine. And we do that when we want to prioritize some VMs over others. And typically, you could do it right there on the individual VM. Where that doesn't work out so well is when you have a ton of virtual machines. The more virtual machines you have, the more difficult it becomes to manage them individually. And so what we have in vSphere is the ability to create a resource pool. And a resource pool can be shared across multiple VMs. It becomes really handy when you're trying to create a set of resources that are available just for one particular group of applications or resources. It's even more handy if you're a service provider. It may be that you're running the hardware infrastructure and you're renting out services to customers. You know, think of like Amazon Web Services or Microsoft Azure, right? When you create those cloud services where you have what are called tenants, right? Customers that are renting your hardware resources, you might need to set up resource pools for those tenants that say, under your agreement, under your contract, you're paying us for X amount of memory and X amount of CPU. This is what we're giving you. And then you can spike and go over, but here's the limits of it, and we can define that. And then that customer can create as many virtual machines as they want, as long as they operate within the boundaries of that resource pool. If they exceed the resource pool, they won't be able to spin up those virtual machines. They won't be able to power things on. So resource pools are a great way to govern that. If you fully own your VMware infrastructure and all of your virtual machines are important to you and you want them all to have access to resources, then you probably won't use resource pools. That if one machine starts to get greedy, you'll probably just add more hardware, right? I'm running low on memory, let me add more memory. So resource pools are really useful when you want to restrict things, and a lot of people don't want to restrict. So know that this is a technology that you might not use a lot in real life unless you're dealing with multiple tenants. Or I'll give you an example of where I've used it is production and dev environments. I've made the mistake before of having a production environment, cloning the production environment to create a dev environment. So I might have 5 servers for a production app, and I clone it, and now I've got 5 more servers for the dev app. I got a total of 10 servers. And the dev team jumps into the dev app, and they start working on it, and they do an experiment. And whatever they did, whatever mad science experiment they cooked up that day, all of a sudden their CPU usage spikes to 100%, and they peg out all their RAM, and they're thrashing the disk, and the production environment starts getting slower and slower and slower because the dev environment's gone nuts, right? It's an easy mistake to make. We assume that everybody's going to play nice until something bad like that happens. So in that scenario, yes, I want the production environment to have access to whatever resources it can get a hold of, but I want to restrict the dev environment and limit that down. And I don't care how many VMs are in the dev environment, I just want to make sure it doesn't impact production. And so I can create a resource pool and say the dev environment has these limits. And I can do it on each individual virtual machine, but anytime I rebuilt that dev environment, I would have to remember to put those settings in place again. And I'm not going to remember. I recognize my faults and I work around them, right? So I know I'm not going to remember. And even if I did remember, it's a lot of work. I might need 20 virtual machines to build that dev environment. Now I got to go and do these settings 20 times. A resource pool lets us define it once, and we put the virtual machines in that pool. And like the name implies, it's a pool. It's a collection of resources. And so each virtual machine just draws a portion of that pool. And when the pool is empty, there's nothing else to give. And that's it. You've pegged it out and you've hit your limit. Now, resource pools are actually pretty easy to work with. On an individual, let's start with the individual virtual machine, right? So if I jump in here, I'm going to go into my hosting clusters and I'll find a VM. So I've got this database server sitting right here, and maybe that database server is important to me. It needs a lot of RAM, it has disk I/O needs, and resource pools really aren't all that useful for managing disk I/O. We'll see there's a few little settings in there, but storage I/O control is somewhat limited in VMware. But I'm going to take that database server, and when I go up here to manage, and then we can go into our settings, and you'll see like CPU and memory that we can define. And this is what the virtual machine is going to see. But inside of those, you'll see where we can set shares, reservations, and limits. Those are what we talked about in the episodes we covered on creating virtual machines, right? And we talked about how a reservation is a hard amount of CPU utilization that we can reserve for this machine. If this machine uses it, great. If this machine doesn't use it, nobody else can. It's off limits. A reservation is just for this machine. A limit says it can use up to this amount of utilization, and if it hits that limit, it stops. It can't use any more. So if I set it to 20%, it can use 20% of the CPU, it can't use 21%. And then shares are for where I don't want to define a reservation or a limit. Shares are used for defining a priority. If there's 3 different virtual machines all vying for access to RAM, who wins? Well, ideally they all win. If I have enough RAM, they all win. But if I don't have enough RAM, it's going to come down to shares. Or if it's CPU, right? This is CPU in this case. It's going to come down to shares. Whoever has the most shares gets priority, and the other people will get a smaller percentage. For CPU, this guy's got 1,000 shares. If I had another host who had 500 shares, and they were both competing for CPU access, this guy would get 66%, and the other guy would get 33%, right? 1,000 shares versus 500 shares. If there were 2 VMs, 2 guests, that both had 1,000 shares, then they'd each get 50%, right? It's equal shares. So that's basically priority. And this is defined on the individual VM. But instead, what I can do is I can go to my host, I can right-click on the host, and this works on clusters too, so you can define it in a number of different ways. And inside of that host, you'll see where I can create a new resource pool. And I can create the resource pool, and you'll see that I've got basically the same settings. Here's CPU, I've got shares, reservation, limit. Here's memory, shares, reservation, limit, just like on the virtual machines. And so I can come in and I can set that. And maybe this is going to be my production environment, right? So this is production servers. And I'll set the shares to high. I want the production server to get more shares. These are like little macros or aliases for certain numbers. If you choose normal, that's that 1,000 shares that we saw earlier. And if you choose high, I believe it's 2,000 shares if I remember right. And if you choose low, it's 500. But the numbers don't necessarily matter because you could always do custom and put in whatever the heck you wanted, right? So I'm just going to put it to high and leave that be, right? I could do a reservation, but it's not that I want to hold the CPU for production. If production's not using it, then I'm fine with somebody else using it. I want to get my money's worth out of the hardware. But I just want to make sure that the production servers have priority access. If they want it, then they get it, all right? Then I can set a limit if I want to cap them. Maybe I don't want production maxing out the server. So I could set a limit. Now in my case, I'm okay with production maxing out because that's my production environment. That's what's supposed to use all this stuff. So I'm going to leave it unlimited. And then I'll do the same thing for memory. I'm going to set my shares to high, and I'll leave my reservation and limits undone. Okay. Now there is one more option that I've skipped over here, which is reservation type. And the default is expandable. What does that mean? Well, if I define a reservation, let's say I define a reservation of 1 gigahertz, and then I create a VM and I give it 500 megahertz, and I create another VM and I give it 500 megahertz. That adds up to a gigahertz, and now I'm covered. What if I create a third virtual machine and give it 500 megahertz? Well, now I'm at 1.5 gigahertz. And if my limit was set to 1, right? So if I come in here and I set my reservation to 1,000 megahertz, right? I create 2 virtual machines at 500 megahertz each, and then I create a third virtual machine at 500 megahertz. I'm now at 1,500. I've exceeded the reservation. If we have it set to expandable, it'll increase my reservation to 1,500, right? It'll automatically bump up to account for the new virtual machine I created. It assumes that because I created the virtual machine, that's what I intended. That's what I wanted, right? That's not always true. That may not be what I intended. And so we can turn that off, and now we're not expandable. And so now if I create 3 virtual machines that have 500 megahertz each, I can power up 2 of them. The third one I can't power up because I've hit the limit and my reservation, and it's not expandable. And so now I'm kind of at the mercy of whether there's processor cycles available. if there's some available, I might be able to get it, but it's not reserved for me anymore. Okay, so that's what that reservation type is. Expandable is the default. You don't always want that. I'm going to go ahead and say OK to that, and that's going to create that resource pool. Now, that was production. My development environment, right? That's a little bit different. So I just created production servers. I'm going to create my dev servers next. So I'll do another new resource pool, and I'm going to call this one dev servers, right, or development. We'll spell it out. Your end users never see this. It's there for you, so making it easy for you to recognize is kind of the nice part there. Now, dev servers are different. It's not like production, where I want them to have access to everything. In fact, I want to make sure that my dev servers never impact production. And the easiest way to do that is to just set their shares to low. If I set the shares to low, now it'll take whatever it can get, but the production server is set to high, it's going to get priority. But if they're both accessing at the same time, it's not that this guy won't get anything, it's that it'll get a smaller percentage. So it's still taking away resources from production. It's just based on a percentage scale, so we may need to adjust that.
And in something like your development environment, Don, would you maybe uncheck expandable because you don't want it oversubscribing the pool to your production environment like you've been stressing?
Yeah, if you do set a reservation, you would absolutely want to turn that off because you don't want it to grow beyond that limit as you create VMs. And if you're letting your dev team create VMs, you could have that, and they could start growing their own pool, even though that's not your intention. So you can do that, but I don't normally use reservations with something like development, right? I don't want to hold memory exclusive for the dev team because I hold memory for production, not for the dev team, or hold CPU. You know, I wouldn't normally do that. I would enforce a limit that let the shares do their thing, but also restrict what they're able to access. So you'll see my max limit is 3.3 gigahertz right now because I've got, I think I've got two 1.5 gigahertz machines or something like that, or 1.5 gigahertz processor, I don't know, whatever. So I do have somewhat of a limit there, but I might want to hold the dev environment to 1,000 megahertz, right? Or you can change it to gigahertz, makes life a little easier. So I'll make it 1 gigahertz, right? So the shares will let me grab up to a gigahertz, but if I try and grab more than gigahertz, it'll stop me. So even if the production environment is not doing anything, it's still got this extra space available. Now, why would I want to do that? Well, just because the production environment has higher shares doesn't mean that it can step right in and kick out the dev environment. If the dev environment is doing something right now, the CPU has to wait for them to finish before it can bring the production environment in. And so on that current cycle, what's being processed right now, whoever's in there is already in there. And it's the next cycle that's going to take effect with the measurement, the shares. The cycles, we're talking about nanoseconds of time here, so it's really, really small. But if you want to make sure the production environment has immediate access to resources, you'll enforce a limit. And that way, there's already guaranteed to be a certain amount of CPU cycles or a certain amount of RAM that's exposed and empty and waiting that we can jump in and access at a moment's notice with no delays. So enforcing a limit can kind of work out really well there. And you can do the same exact thing with memory. So I might limit my dev environment to, I don't have a ton of memory available here, so I'll just say like 100 megs. Obviously you want more than 100 megs. Not much you can get done with 100 megs of memory these days, but we can get that set. Now it might be that in your environment, just doing the low and high shares is enough to achieve your goal. That's going to make sure that the production environment always has priority when it goes to access those resources. Right. So we can divide that up. And now we've got it divided up, and I've got my development and production server pools.
Now, once you've got your resource pool created, Don, how are we going to get our virtual machines there? Is that going to be something that you associate them with?
Yeah, it's actually pretty easy. It's kind of like the vApps, the virtual apps. That once you've got these things created, you just drag and drop your machines and drop them right in there, right? So, or if it is, you can drag an entire vApp and drop it in there if you wanted to really go nuts. But I've got these two servers, DB01 and Web01. So let's say the DB01, that's a production database, right? So I'm going to just drag that one right up here, and I'll drop that on my production, okay? And then I'll take Web01, and I'm just going to take it, and I'll drag and drop it up to development, right? And so it's in development, it's working, the dev team is building it up and testing it and making sure that everything's okay. And then one day they call me and they say, hey Don, that Web01 server we've been working on, it's done. It's fully tested, everything's the way that we want it, so we're ready to move it into production. Well, you know, we expose it on our firewall or whatever to truly move it in production. But then as far as resources, that's when I say, okay, time for this guy to go mainstream, let me just drag that and drop it into production. and now it's a production server. And so I don't have to go and edit the individual VM settings. It gets those settings right from the reservation.
Don, in a previous episode, you showed us how that, in deploying vApps that the association was already made. You dropped both of those servers in there, and in the background, it handled the associations. You didn't have to go in and do any post-configuration. Is it safe to assume that it's the same way when you drag this into the resource pool? It, under the hood, vCenter does that for us?
Yeah, once the virtual machines are in there and they're powered on, I'll power one on here real quick, but once they're powered on, then we'll be able to actually see some of those resources getting consumed, and you can monitor it right from the resource pool. So if we jump in here, I'll take my production servers resource pool, and I've got DB01 is powered on now. And when we jump into our monitor tab of the resource pool, you'll mostly see alerts here. We don't necessarily care about that. But when you start to look at some of the other things like the performance tab and the utilization tab and these guys, it's going to run a little slow while it loads here for me. There we go. Now we can start to see how much of the CPU and memory is being consumed, what's active, what's reserved, right? I've got that 1 gigahertz reservation we made, any limits that are defined, the shares that have been issued out. I can see share, I said high earlier was 4,000, looks like it's actually 8,000. So that high share issue I did was 8,000 shares, and you can start to spot the amount of memory. So we can monitor what's actually being used. And if you go over here to resource reservation, this is where you can monitor it a little more accurately, because you can see like the CPU side, and you can spot what of the reservation is being used and the individual machines and what their reservations might be set to see if it's conflicting with what's defined in the resource pool itself. So we can monitor all that right from here, and it's kind of nice because you can see the pool as a whole. I guess mine's looking at a 1-day range here, which is not going to have data yet. After you run it for a few days, you get some really good information in here, and you can start to spot that, and you can see what else is going on with the resource pool. All right, another neat thing is, earlier I gave the example of what if you had tenants, right? And so if I had a tenant that, just a customer that I'm renting out server access to, so I create a resource pool from them. And then they call me and they say, hey, Don, we have a production and a dev environment and we'd like to set up what you've got. Well, you can actually do multi-tiered resource pools. Let me show you what I mean on that. I'm going to create another resource pool here, just a kind of a default one. So I'll do a new resource pool, and I'm just going to call it customer 1, right? Customer number 1. And I'll set whatever limits that customer is paying for. So when they sign up for a contract with me, I tell them these are the resources I'm going to give you, and there's your pool. And so all of their virtual machines are going to go into this customer 1 pool. But if you right-click on the pool, you can actually create a resource pool inside of it. And so I might create a production and a dev pool right in here for them, right? So this might be production and development. All right, and I'm just going to give my screen just a second to update. There we go. And now I've got the customer 1 pool, and they've got a development and a production inside of it. So you can nest these and create a multi-tiered reservation pool. So they might have shares allocated here on these sub-level resource pools that are pulling from the primary resource pool, which in turn is pulling from our server as a whole. So you can really get complex with these things, and it's just a matter of dragging and dropping entities between them to get those resource limits put in place. Now, speaking of multi-tiered, it did just remind me of another technology that we have. Here we're handling our resource allocation, and we're trying to make sure that important machines get access to the resources they need. There is a special type of resource that we can issue out called vFlash, and I know I don't have a ton of time left in this episode, but I want to cover vFlash because it's important. Normally, when we talk about our virtual machines running, the CPU is the host CPU, and the RAM is the host RAM, and the disk I/O is generated from wherever your data stores happen to be, right? And when we set these allocations, I mentioned how we really can't do much for disk I/O, that the storage I/O control is kind of limited. Well, that is true. But we can also set up what's called vFlash. vFlash is like cached memory that's available for our virtual machines. And when I say memory, I mean disk storage memory, not RAM. So if I have a virtual machine that does a lot of read activity on the disk, I can assign them some vFlash, and now they'll benefit from the performance gains of that and be able to take advantage of it. I need to define that, though, and get it set up and enabled. And where we set that up is we set it up in a couple of different places, but it's mostly set up on the host itself up here. So the host is already allowing me to divvy up RAM and CPU for these resource pools, but the host is not set up for vFlash. The way vFlash works is you need to get some SSD, right? Solid state digital memory. And if you have a solid state drive, you can throw it in the system, and it might be one of those 3.5-inch laptop looking drives you add to your server, or it might be one of those mSATA memory cards that sticks right on the motherboard. But it's SSD. You'll normally find 128 gigs, 240 gigs, maybe even 500 gigs of this memory you throw in the system, and then you can make that available for accelerated resource access for your virtual machines. All right. If I remember it, I think I do actually have an extra drive in ESX host 01. We can find out real quick. I'm going to take that host. I'm going to go to Manage and Storage. I'm going to go down here to storage devices and see what I've got to work with in this host. And, oh, actually, you know what? I don't, do I? Well, if I had a little extra storage I could use, I can just reuse one of these other drives, though. So, for example, I've got this 512 gig drive here, assuming I haven't used it for anything. It's showing as flash, and so I can use it for vFlash. If it was misdetected, right, it might get detected here as like a regular spinning disk. Then if that happened, this button would change to show an F, and I could click that and flag it as flash. But it's usually pretty good about detecting it. So I've got this 500 gig one. I'm pretty sure I'm not using that for a data store or anything, so I can go ahead and use that for my vFlash. All right. So what I need to do is I need to tell the system that it's going to use that as vFlash. Quick caveat here. vFlash accelerates reads. It doesn't accelerate writes. You can't optimize your writes. It assumes that every write is unique. VMware said that that might change in the future, but it hasn't yet. So for right now, it's read acceleration only. So if you've got a database that's constantly reading the same data over and over again, it'll really benefit from this. If you have a server that's doing a lot of unique stuff, though, it may not benefit as much. All right, so what I'm going to do is I'm going to go up to my host, and if I right-click on the host and go to the storage menu, under storage, you'll see where we can add virtual flash resource capacity. Okay, it's a resource, just like our resource pool where we saw CPU and memory. Now we're talking about something that accelerates storage. And so I'm going to choose to add that resource capacity, and it's going to show me any suitable disks. Notice how I had a 40 gig disk for the OS. It doesn't show up here because it's already in use. If I had magnetic disks, ones that show up as HDD, they wouldn't show up either. But because I've got this one I'm not using that's 500 gigs, I can use it. And it's just an actual hard drive. It's not like a dedicated chip, but it'll work just fine because they're really all the same on the inside. If you crack open those drives, there's usually a tiny, basically an mSATA board inside of there. It's not anything too spectacular. So I'm going to choose to use that disk, and I'll say OK. And now it's going to add that as a resource to my server. So now my server has some vFlash available to it. This host, this ESX host right here, it's got it and it's available. Okay, but I don't really see anything too spectacular. Things don't look much different. If we go back under Manage and we go back under Storage, what we're going to see is that we'll have a new option in here to customize, or actually it's not under Storage, it's under Settings. So I'm choosing my host, I'm going to Manage, and then Settings. And under Settings, we'll have some nice shiny new options buried away in here somewhere, way down at the bottom, for Virtual Flash. I've got Virtual Flash Resource Management and Virtual Flash Host Swap Cache Configuration. Okay, the host swap. That's if I want to use this flash for the host. If the host OS needs more memory, if it needs more resources, it can use this flash. That's not normally what we want. That's not normally the point of the flash. The point of the flash is to accelerate our virtual machines. So while we can set it up to work with the host, the default is 0 gigs are assigned to the host and that's it. But we can edit that, and we can assign a certain amount of that vFlash to be usable by the host. Okay, default is 0 because that's not its purpose. But if I edit this and increase that number, I can enable the virtual flash host swap cache. It is next to impossible to say. And then I can add the amount of memory that I want allocated for the host. But I'm not trying to accelerate the host. The host isn't doing a whole lot for me. I want to get it set up for my VMs. And so I'm going to choose Virtual Flash Resource Management. And right over here, we'll see that right now my capacity is 510 gigs. It grabbed that whole drive and it's got available. It's for my virtual flash file system. It's up, it's going, and I see the device that's tied to it. It's now set up and it's ready. If I have more flash disks available, I could add them in here. You can add more than one. Right now I just have the one, and so I've got 500 gigs and that's it. Okay, so now that I've got it, I can enable this, and this one unfortunately has to be enabled per VM. So I go to the individual VMs and I say, oh, here's this flash that you can use. right? So if I go and find a virtual machine, I'm going to take my database server, right? Well, the database server's powered on. Let me take my web server because it's powered off. I'm going to take my web server, and I'm going to go into its management, its virtual machine settings, and inside of here, I can go to the VM hardware, and I need to edit the VM hardware. And in the VM hardware, we'll be able to configure that flash. Now, when you look at your flash right away, when you look at your VM hardware right away, you're not going to see a whole heck of a lot in here, right? And that's because it's tucked under the hard disk. So I've got to find my disk where it's defined in here. Right here, I've got hard disk 1. And I can expand that out. And in here, you'll find the virtual flash read cache, right? That's where I can start to assign the memory that's set up in vFlash to this VM. And I can give it the whole thing if I want, or I can give it a portion. I can say, you know what? I'm going to give you 16 gigs of vFlash to use. Okay. Now, as soon as I did that, I got a big warning that popped up on my screen, and you'll see my reservation must be between 4 megs and 8 gigs. The number entered in is too large. Enter 0 to disable it. Okay. I tried to allocate too much, and that's because of the hardware version and the system is set up. It's got its own limit. So I need to cap mine at 8 gigs. There we go. Now I've got 500 gigs, so I've got plenty more left over. I can go to other VMs, or if I had more than one disk in this VM, I could add it to each disk. It's done each disk individually, so I could have 3 hard drives and only accelerate 2 of them if I wanted. And now I'm improving that performance and adding it in. And if I go to advanced, you'll see here where I can actually specify a block size too. I've allocated 8 gigs of storage. No matter how small of something it writes to it, it's always going to consume at least 8K. If I've got large stuff being written to it, I don't care, that's fine. But if I'm dealing with tons of small files, I might want to choose a smaller block size to make it a little more efficient. And you can choose bigger block sizes too. It's all about making it a little more efficient as far as how that memory uses. But that 8K size is pretty industry standard, and so most of us just leave it right there at that. But now I'm accelerating disk access here by giving it access to vFlash, and it's done per VM. So I don't have to set up a resource pool for this. I set it up on the disks themselves. It's a lot more manual, but you have a lot more control, right? But you'll also see in here some of the storage I/O control. I can limit the input-output operations per second, the IOPS. I can set shares, and this is on the disk. The resource pool wouldn't let me set this, but I can set it right here on the disk for the VM. So this kind of goes hand in hand. I don't get the nice centralized management of it where I just drag and drop VMs into a pool and it's done. I have to configure it here by hand, but I do have the capability. So when it comes to managing resources, pools are great for CPU and RAM, but for disk and even network, we end up having to come down here and set it. Network I/O control and storage I/O control, NIOC and SIOC, are done right here. The NIOC we can actually do on the port groups of a switch, and SIOC we can actually do on the data store itself too if we wanted, but we can do it right here from the VM, and it's a lot more granular. So a couple of different ways that we can allocate those resources out.
Don, we definitely appreciate all the information on the resource management, and it does look like you could get yourself into trouble with peeking and tweaking these wrong if you don't pay attention. Looking at the clock, though, it does look like we're coming to the end of another episode, but before we do you got any additional words for the viewers?
One thing I forgot to mention is I now have vFlash attached to that VM. I can't use vMotion anymore, because if I move it to another host that doesn't have vFlash, I'm in trouble, right? So vFlash can actually be configured on a cluster also. So if you have a cluster of hosts, you want to make sure you put flash in each one of them and then create the vFlash on the cluster. That way you can still use vMotion. The way I just set it up would be a vMotion disaster, right? If you're not using vMotion, you don't care. But just be aware that you can create it on the cluster. It's done exactly the same way I just did it, except on the cluster, not on the host. Just keep that in mind.
Don, as always, we appreciate you being here in the IT Pro TV studios, and we appreciate you, the viewer, watching us. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.